Imagine your phone dying right before you capture the perfect shot for Instagram. Frustrating, right? But here's a question. Do you know why your phone even had power in the first place? The answer lies in the invisible but incredibly powerful world of electrical circuits, where voltage, current, and resistance work together like the ultimate tech squad to keep your gadgets alive and kicking. So, what's the deal with electrical circuits? Picture this: a circuit is like a road trip for electrons, where voltage is the map, current is the flow of traffic, and resistance is that annoying roadblock slowing you down. Sounds simple? Well, hold on tight because we're about to break it down in a way that'll make you see your gadgets, and the electricity that powers them, in a whole new light. First, let's talk voltage. Voltage is like the driving force behind the flow of electrons, the oomph that pushes them through the circuit. Imagine you're at the top of a roller coaster. The height gives you potential energy. The higher you are, the more potential energy you have. In the world of circuits, voltage is that height, giving electrons the energy they need to zip around the circuit. Without voltage, nothing moves, nothing works, and your devices stay dead. Voltage is measured in volts. Shocking, I know, and it's the reason why your phone charger, your laptop, and even your toaster can do what they do. But voltage isn't doing all the work alone. Enter current, the actual flow of electrons through the circuit. Think of current as the river of electrons, flowing from one point to another, carrying energy along the way. The more electrons that flow, the higher the current. And just like water in a river, the current can vary. Sometimes it's a gentle stream, and other times it's a raging flood. In the electrical world, we measure current in amperes, or amps for short. The higher the amps, the more powerful the current, which means more energy is being delivered to wherever it's needed, like your phone when it's charging. But wait, there's a twist. Just like every river has rocks and debris that slow down the flow of water, every circuit has resistance. Resistance is the party pooper of the electrical world, putting the brakes on the flow of electrons. It's what keeps the current in check, preventing things from getting out of hand and turning your circuit into a fried mess. Resistance is measured in ohms, and it's the reason why your phone doesn't explode when you plug it in. It's a necessary evil, controlling the flow of current so that everything works smoothly and safely. Now, let's put it all together. Voltage pushes the electrons, current is the flow of electrons, and resistance is what keeps the whole system in balance. These three amigos work together in perfect harmony to create what we know as an electrical circuit. Without any one of them, the circuit just wouldn't work. Imagine trying to drive a car with no fuel, no road, or a roadblock every 5 feet. It's not going to happen. Voltage, current, and resistance are the key players, making sure that energy gets where it needs to go and that your devices stay powered up. But here's where things get really interesting. The relationship between voltage, current, and resistance is governed by one of the most famous laws in the electrical world, Ohm's law. Ohm's law is like the golden rule of circuits. It states that the current in a circuit is directly proportional to the voltage and inversely proportional to the resistance. In simpler terms, if you increase the voltage, the current goes up. If you increase the resistance, the current goes down. It's a delicate balancing act, and understanding it is the key to mastering circuits. But why should you care? Because circuits are everywhere. They're in your phone, your computer, your car, your home. They're the backbone of modern life. And once you understand how they work, you can start to see the world in a whole new way. You'll understand why your phone charges faster with a higher voltage charger, why certain devices need more power than others, and why your circuit breaker trips when there's too much current. And it doesn't stop there. Understanding circuits opens up a world of possibilities. Want to build your own gadgets? Start with circuits. Want to hack your devices to make them do more? Start with circuits. Want to design the next generation of tech that changes the world? You guessed it, start with circuits. Voltage, current, and resistance may seem like abstract concepts, but they're the building blocks of everything electrical. Master them, and you've got the power to create, innovate, and change the world. So, next time you plug in your phone, flip a switch, or power up your laptop, take a moment to appreciate the tiny electrical circuits working behind the scenes. They're not just a bunch of wires and components, they're the lifeblood of the digital age, the unsung heroes that make our modern world possible. And now that you know their secrets, who knows what you'll create next?